Welcome to this specialized module on AWS infrastructure for Cloudera Data Platform. Today, we are focusing on Amazon Elastic Kubernetes Service, or EKS, and how it powers the modern data services within CDP. We will move beyond standard VM-based clusters and explore how Cloudera leverages container orchestration. Let's define what EKS does here. Amazon EKS is the backbone for Cloudera's containerized experiences. While traditional data hubs might look like a collection of virtual machines, Cloudera Data Warehouse, data engineering, and machine learning are different. They leverage EKS to orchestrate containers. This means when you activate these services, Cloudera provisions an EKS cluster on your behalf. The control plane of Kubernetes is managed by AWS, but the worker nodes where your actual data processing happens live securely inside your customer VPC. This flow shows the provisioning hierarchy. The Cloudera control plane initiates the creation of the EKS control plane, which is a managed service in AWS. This control plane then manages the worker nodes that reside inside your specific virtual private cloud. Finally, the actual data services, like data warehouse or engineering, run as containers on those worker nodes. Why do we use EKS? The primary driver is elasticity. With EKS, Cloudera services can automatically add more EC2 instances to the cluster when a heavy SQL query or Spark job runs, and terminate them when the job finishes, saving costs. Secondly, Kubernetes namespaces provide strong isolation, allowing different teams to work on the same infrastructure without interference. Finally, this architecture allows for shared compute pools, meaning you don't need idle servers waiting for work. Resources are provisioned strictly on demand. Here we visualize the efficiency engine. The EKS cluster monitors the workload demand. If demand is high, the AWS autoscaler adds nodes. If demand drops, it removes them. Both paths lead to cost optimization, ensuring you only pay for the active compute power you utilize. Networking in EKS requires specific attention. The Kubernetes API server endpoint exists in the AWS managed account outside your VPC. Your worker nodes, running in your private subnets, connect to this API server. For your users to access tools like Hue or the JDBC endpoints, Cloudera provisions an ingress controller behind an AWS load balancer. This routes traffic from the edge of your network directly to the specific pods running your applications. This diagram separates the AWS managed layer from your customer VPC. The EKS API server sits at the top, managed by AWS. Inside your VPC, the worker nodes in the private subnet reach out to that API server for instructions. Meanwhile, user traffic enters through the load balancer on the left, which directs requests to the appropriate containers on the worker nodes. For high-security environments, you will use private EKS clusters. This configuration restricts the EKS API server so it's not accessible via the public internet. Connectivity is maintained using Cloudera's Cluster Connectivity Manager, or CCM v2. CCM creates a secure, reverse HTTPS tunnel from your VPC out to the Cloudera control plane. This ensures that Cloudera can manage the cluster lifecycle without you having to open any inbound ports on your firewall. The sequence diagram illustrates the secure flow. The EKS cluster communicates with the local CCM agent. The agent initiates an outbound HTTPS tunnel to the Cloudera control plane. The control plane sends management commands back through this established tunnel, which the agent then applies to the cluster, maintaining security without inbound gaps. Security in AWS revolves around IAM. Cloudera requires a cross-account role to essentially drive your AWS account, creating the EKS cluster, scaling groups, and load balancers. Furthermore, the worker nodes themselves need an instance profile. This allows the pods running on those nodes to talk to S3 for data storage or RDS for metadata without hard-coded credentials. For strictly regulated environments, Cloudera offers a reduced permissions mode to minimize what the cross-account role is allowed to do. Following the permission flow, Cloudera control plane assumes the cross-account role in your AWS account. This role allows Cloudera to provision the EKS cluster. Once running, the EKS cluster utilizes the worker node IAM profile to securely access backend resources like S3 buckets and RDS databases. How is data stored? Persistent business data always resides in S3. However, EKS pods need fast, temporary storage for operations like caching or shuffling data during a Spark job. For this, Cloudera configures the nodes to use local NVMe storage or dynamically provisioned EBS volumes. Cloudera handles the installation of the necessary CSI drivers on the EKS cluster, so when a pod requests disk space, AWS automatically creates and attaches an EBS volume to the worker node. The pod sits at the center. For long-term persistence, it writes to the S3 bucket shown at the top. For immediate fast storage needs like caching, it utilizes EBS or NVMe storage below. The CSI driver is the invisible hand that automatically provisions that block storage whenever the pod requests it. Finally, let's discuss the lifecycle. AWS updates EKS versions frequently. Cloudera certifies specific versions like 1.28 or 1.30. When it's time to upgrade, say from 1.29 to 1.30, you often cannot just click Upgrade in AWS. The Cloudera recommended path usually involves a backup and restore workflow to spin up a new EKS cluster with the latest version. Additionally, you can rotate the underlying AMIs of your worker nodes to apply OS-level security patches without taking down the whole service. This flow shows the upgrade logic. When an EKS version like 1.29 is deprecated, action is required. Path A shows the major upgrade process. Back up the configuration, then restore it to a brand new EKS v1.30 cluster. Path B represents routine maintenance, where you rotate AMIs for security patching without changing the Kubernetes version.